Hello, class. We are now moving on to the fourth lesson of the unit. So you should have already learned how to define a function, how to use function notation. Yesterday, you should have learned how to identify types of functions. Now, today, we're going to graph discrete functions and sequences. Now, if you remember, a discrete function is a function that is broken up into distinct points. So we're going to look at this example. Jalen is a stamp collector. Every Monday, Jalen buys 3 more stamps. How many stamps does Jalen buy after 6 weeks? So if we want to graph this, we have to first label our axes. So on the x-axis, we're going to have weeks, since he buys 3 stamps each week. And on the y-axis, we're going to have stamps. Now we want to know how many stamps he's going to buy after 6 weeks. So we're going to have 1, 2, 3, 4, 5, and 6. And then on the left, we can go up by intervals of 3 since he buys 3 each week. So we'll have 3, 6, 9, 12, 15, 18, so on, all up to 21. So after the first week, he's going to buy 3 stamps. So we're going to have a point right here. Now, remember, this is a discrete function, not a continuous function. He's not slowly buying stamps each week. He's getting 3 more all at once. So at the second week, we're just going to have another point right here. If we connected those points, that would make it seem like in between weeks 1 and 2, he had at some point 4 stamps and 5 stamps and 5.5 stamps and so on. He doesn't have any amount of those stamps at any time. He always gets them in intervals of 3. So at the third week, we're going to go up to 9 stamps. On the fourth week, we're going to go up to 12 stamps. At the fifth week, we're going to go up to 15 stamps. If this dot will work. Anyway, there should be a dot right there. And then on the 6th week, he's going to go up to 18 stamps. So as we see here, he's got 3, 6, 9, 12, 15, 18. So after 6 weeks, he's going to have 18 stamps. Now, would this be continuous or discrete? I already said discrete, because he is only buying in increments of 3 stamps. So he never has 4 or 5 stamps. That's why the line's not connected. So if we want to look at a sequence that's a little bit harder, we have the Fibonacci sequence. So the Fibonacci sequence is one of the most famous sequences in the world. Basically, the sequence is made where the next number is always the sum of the 2 numbers before it. So we're going to graph this sequence in terms. So the first term is going to be 0. The second term is going to be 1. And then each term after that is going to be made from the adding together the 2 terms before it. So the third term is going to be 0 plus 1, which is going to equal 1. The fourth term is going to be 1 plus 1, which equals 2. The fifth term is going to be 1 plus 2, which equals 3. The sixth term is going to be 2 plus 3, which equals 5. The seventh term, 5 plus 3, is going to equal 8. And then finally, the eighth term is going to be 5 plus 8, which equals 13. So as you can see, it starts going up slowly and then starts going up faster. So we have our first term is going to be at 0. Our second term is at 1. Our third term is at 1. Our fourth term is at 2. Our fifth term is at 3. Our sixth term is at 5. Our seventh term is up here at 8. And then our eighth term isn't even on here. It's going to be up here somewhere at 13. So the first thing we do when we look at this, we can see this is not a linear function. It's not going up by the same amount each time. The first time it's going up by 1, then it's going up by 0, then it's going up by 1 again, then it's going up by 1 again, then it's going up by 2, then it's going up by 3, and so on. So this is a nonlinear function, or we don't even know if it's a function, but it's definitely nonlinear. And then, so that's it graphed. So is the Fibonacci sequence a function? Yes. Because each input, which in this case, the inputs are terms, each input is only going to have exactly one output. Now, you might think it's not a function because the second and third term are both 1, but remember, you can have the same output as many times as you want, or you can have each output as many times as you want as long as they're to different inputs. We never have a situation like this where we have 2 dots on the same vertical line. So each input has exactly one output, so it is a function. So I hope this helped make sense for discrete functions a little bit. Remember, you're only plotting points. You don't have to connect them because there's no like 1.5 term or 2.6 term. Connecting them makes it seem like we're filling in all the numbers in between it. So good luck on your practice and have a good day.